Good afternoon, everyone. My name is Ta Xiaohua and come from University of Chinese Academy of Science. The topic today I will talk about is enforcing ACL on access control on Android platform. And I will talk about the topic from the following aspects. In Android, it defines permissions respond to resources, and when an application installs, all the requested permissions are present to user, and if user allows these permissions, then the granted permissions will stored in package manager service. And there are two ways for application to access the resources. The first one is the application level layer, and the other one is kernel level layer. The first one, application level layer, is based on application's UID. When application installs, it will allocate it with a Unicode UID, and it can access the resource by system API offered by system service. And at that time, check permission, and at that time, permission check request with a stream of applied permission, and the caller's PID will send it to system server, and the check permission in system server will check the permission. But however, any applications can run native code like C or C++, and this make them bypass the framework layer permission check. And the system files, device files can be accessed directly without check permission in system server. Android imports a discretionary access control to avoid this. And in kernel level layer, Linux kernel use UGL to import stack, and UGL usually imports control through group instead of UID. That means sorry. That means the system is unable to authorize a certain application access resource according to its UID, but the user in the same group has the same permissions to access the object, and this is a coarse-grained permission mechanism. So to authorize permission to a specific application is infeasible, and some weakness may remain, like a transplantation attack. And let's see some normal permission access flows and transplant attack. If an application wants to obtain a resource, it it will send a request to relevant citizen service and then call citizen server to check the permission. If yes, the service can call citizen libraries to interact with hardware and return the result back. By embedding malicious code in install package and repackage it, malicious code can copy system libraries from system server process space to its own process space. So the application can use these libraries to access hardware driver or software resources directly. And this picture shows a normal photo taking overflow and how one type of transplantation attack applies to the camera. When an app wants to take a photo, it will send a request to media service, and then media service call system server to check the permission. Transplantation attacker transplant the needed library from this service to its own application process, so it can use this library to take a photo and without interact with media service. And we introduced ACL in this system. And what is ACL? ACL is a list of permissions attached to an object, and it can provide an additional and more flexible permission mechanism for file system. And as we mentioned before, Android uses UGL to enforce stack, and UGL uses NIPs to identify the privilege of user group and others. So if we want to give two different users different rights respectively, it will fail to accomplish it. But ACL can make it come true. Each entry in ACL specify a subject and an operation. So ACL can assign multiple users and groups different access policies to a certain object. And this is the system architecture of our system. The system can set each application's access permission for a given object, and the system consists of three parts: ACL control center, ACL service provider, and ACL support. And the ACL control center is responsible for interacting with users, and ACL support is the most important part in our system. It transplants ACL from Linux to Android. And the ACL control center, it has two parts. Permission monitor requires the resource access permission of which application can access in real time, and it records all the operations that performed on a specific file. And permission handler controls the access of resources through sending a command to ACL service provider. ACL service provider service client and communicate with service server through socket, and the server receives the message and will call libACL to operate the command. And as for ACL support, it contains 3 parts. Shared library support provide a shared library entitled as ACL. And Bionic support is Android C libraries. Linux kernel support. And in Linux kernel support part, we recompile the kernel so it can in favor of ACL. And then I will describe the implementation details of some crucial components. Android open source project use a shrinking and compiled kernel, and it doesn't support ACL in file system. So we have to recompile a new kernel. Following table shows the argument changed before and after. We reset the values concerned about ACL, and after replacing a new kernel, ACL can be one of the file extended attribute in ext4, and this information is installed in files inode. In shared library support works on transplanting ACL code from